Algebra 2, Reteach number 3. First, I want to start out with a quick review of how to multiply fractions. When we multiply fractions, all this is saying is that we are timesing by 3 and 4, right? And we're dividing by 2. And it doesn't matter what order we're doing it in. We can do either or in any order, but we have to do both, right? Because it says divide by 2 and it says times by 4, right? So 3 times 4 is our first option, or we can do 4 divided by 2. Doesn't matter which one we do, but we have to do both. And again, that's just what this says. This is no trick. This says 3 times 4, and it says divide by 2. Doesn't matter whether we do 3 divided by 2 first, or we do 3 times 4 first. In this case, I'm going to do 3 times 4 first, and I'm going to get 12. And then it says divide by 2. You could leave it like this, but we both know this simplifies to 6. You could alternatively, like I said, instead of timesing first, you could divide first. I probably don't want to do 3 divided by 2 first, but you could. Instead of dividing 3 by 2, I'll divide 4 by 2, and then I'll times by 3 later. So 4 divided by 2 is 2. And then if I times by 3, I get 6, which is the same answer, as it should be, because it doesn't matter which order you do it in. That's something I wanted to look at real quick. Another thing I want to look at is when we have an equation like y equals 3x plus 5. Right, this is solved for x, or sorry, let me say it again. Solved for y in terms of x, right? That's what this is. It is solved for y because y is on its own, right? It equals something. If I told you y equals 3, we solve for y, right? Well, I'm telling you y equals all this, right? So it's solved for y, and it's in terms of x because all the terms over here don't have y in them, they have x in them, right? So when we're solved for y in terms of x, we have something like this. And if we want to reverse this process and solve for x in terms of y, we can just apply what we learned in pre-algebra, right? Let's get rid of the 5, let's get rid of the 3. It doesn't matter what order you do it in, as long as you do it correctly. When we subtract or add to both sides, we just do it to both sides. So if I wanted to minus 5 from both sides, totally fine. What I would end up with is y minus 5 on this side, right? If you can imagine with me, subtracting 5 from the y, I would get this. And then I would divide out that 3, right? And when you divide by something or multiply by something, unlike when you add or subtract, you have to do it to every single term. So when I divide by 3, I do it to everything. So I divide it out this side, it gets rid of the 3. The 5's already gone, right? I moved that over here, basically, right? So when I divide by 3, I divide everything by 3. And we've got our solution for x in terms of y. Now, alternatively, instead of subtracting 5 first, you could have divided by 3 first. And when you do this, remember, you divide everything by 3. So this I'm actually going to show my work for. When I divide everything by 3, that means every single term, both on the left side and the right side, gets divided by 3. The reason we did this is these divide out, right? Anything divided by itself is 1, and so we get x on its own, which is nice. But over here, 5 divided by 3 does not divide out. We get 5/3, right? That's what 5 divided by 3 is. And y divided by 3 is just y over 3, or y divided by 3. And now, just like we did before, where we subtracted to get rid of the 5, right? We want to remove this entire term to get x on its own, right? So we would subtract 5/3, because anything minus itself is 0, and we want the whole thing to be gone. The reason we divided here instead of subtracting 3 is because this will remove the 3 but leave the x, right? We wanted to leave part of the term, right? Whereas this, we want everything gone, so we're going to subtract it. Then, of course, when we subtract, we just do it to both sides. Notice I'm not subtracting it from the x. Like when we divided, we did it to everything, right? This, you just do it to both sides, and you combine like terms. So I get y over 3 minus 5 over 3 equals x. And of course, if you wanted, because these are like terms, they're both thirds, we can combine it to be this, y minus 5 all over 3, which is exactly what we got up here. So any of these are acceptable. These are all x's in terms of y. You can do it in any order you want. You just need to know how to do it, right? The common mistake here is when you divide, you forget to divide this guy, right? A lot of people just leave that as a 5, but that is not correct. You've changed the problem if that's the case. You had to divide everything. Whereas adding or subtracting, you just do it to both sides, combine like terms, right? Cool. I want to look at another one, similar problem to this. It's y equals 3/7 x. plus 5/11. Now, sometimes you'll see the problem looking like this. Other times you'll see the problem looking like this, where the x is combined with the 3 up top. Like that. And it makes sense that these are both the same because remember, when we multiply by a fraction, we times by the top and divide by the bottom. So here we have x times a fraction, right? That's what's going on here. They're multiplying. That's why they're next to each other. So we have 3 times x divided by 7. So another way to write that would be 3 times x, or 3x, right, divided by 7. So these are exactly the same. You can switch back and forth between them if you want, right? 3/7 times x is the same thing as 3x divided by 7. But I'm going to look at it this way, because I prefer this. And so you can see from what we did previously, right? We subtract 5 and then we divide by 3. That's what we did for this problem right here, right? We can do the same thing here. We can get rid of this part, or we can get rid of this part first. It doesn't matter. It's up to you. So first you might want to subtract this, kind of like we subtracted the 5 early on. What we'll end up with is, if we're trying to get x on its own, right, in terms of x, we'll subtract the 5/11 from both sides. That'll remove it from here and subtract it from y. And then remember here what we did, right? We divided out the 3 because we wanted to leave the x behind, right? So we're going to divide by 3/7. And a lot of you guys are doing this, right? Which is totally fine. This is a valid answer. It's just kind of gross looking, right? Because we're dividing by 3/7. But that's a valid answer, totally fine. This might be the case where instead of subtracting first, you might want to actually take care of this first. And there's a couple ways to do that. One way is to do this, where instead of like when I did this, I divided by 3 first, right? That was my first step. I could divide by 3/7 to everything. I get y divided by 3/7. And then I would subtract 5/11. But then 5/11 is also going to get divided by 3/7. In fact, let me show my work on this so you can see exactly what I'm talking about. So if I divide everything by 3/7, right? Because that's what happens when you divide. You have to divide everything. What I get is y over 3/7 here. Over here, these divide out because anything divided by itself is 1. So I get x. And then 5 divided by 11 divided by 3/7. This looks complicated, but it's not. Instead of dividing by 3/7, what we can do, instead of dividing by 3/7, what we can do is we can multiply by the reciprocal. 7/3. And the reason this works is because timesing by 1/2 is the same thing as dividing by 2, right? They're reciprocals, 2 and 1/2, right? So 2 is the reciprocal of 1/2. And dividing by 2, cutting something in half, is the same thing as multiplying by 1/2, right? So timesing by the reciprocal of a number is the same thing as dividing by that number. And it's much easier to multiply. We multiply across, not cross multiply. 3 times 7 is 21. And 11 times 3 is 33. Now you might notice this needs to be simplified. We get this, 7 over 11. You could have also noticed that not cross multiplying, that's not what we're doing here. This says 3 divided by 11 times 7 divided by 3, right? We can do it in any order. We could do 3 divided by 3 first. It doesn't matter what you do, it's all one term. So if we take 3 and divide it by 3, these divide out and we get 1. Notice we're not cross multiplying here, right? All I'm doing is just, it's listed out that I have to divide by 3 eventually. So why not divide 3 by 3? I couldn't divide 11 by 3 because again, I'm saying divide by 11. Right? So you wouldn't divide 11, divide 3. But you would take 3 divided by 3. And I would get 1 times 7 and 11 times 1, which is 7/11. So for this, when I divide by 3/7, it's the same thing as timesing by 7, dividing by 3. So when I do that, and times by 7 and divide by 3, what I'm left with is this. 7/11. At this point, you might want to subtract. And you'll have x. So this also works, in addition to the way we did it here, right? The best way, in my opinion, is to do it this way. I don't like fractions. I don't like having to deal with them. And so what I do is instead of dividing and doing what I normally do, What I'm going to do is I'm going to change the problem a little bit, or not change the problem, I should say. I'm going to say, look at it in a different way. So if I times everything by 7, because again, when I multiply or divide, I have to times everything. What I get is 7y equals 7 times 3 divided by 7. I'll divide the 7s first and get 3x, because that's why I did it, right? Timesing by 7 actually gets rid of this division, right? And over here, it doesn't get rid of anything, because I'm not dividing by 7, right? So 7 times 5 over 11 is 35 over 11. And I can do the same process again to get rid of this divide by 11. I can times every term by 11. You get 77y, 33x. And then, of course, I did this so these would divide out. 11 divided by 11 is 1, times the top is 35. And while the numbers are bigger, I don't have fractions anymore. And so now I can solve it just like a regular problem. If I want to get x on its own, I'll subtract 35 and divide by 33. Bigger numbers, at least they're not fractions. The last problem I want to look at is similar to all of these. And it's one that a lot of you guys had a question about. It's this problem. And this problem has multiple iterations, right? One version where we're solving for b in terms of a, c, and x, right? So we get b on its own. One where we're solving for x in terms of a, b, and c. So a, b, and c will be on the right, x will be on the left. And one where we solve for c. And this is the one that stumps the most people. And the reason it is because c is on the bottom, right? We can't just get rid of it like we normally do. So instead, let's apply what we just learned. We don't like fractions. That's kind of the problem, that c is on the bottom. So instead of going about our business as usual, let's, simplify the problem a little bit before we start. By timesing every term by c, these divide out and I get x minus b times c equals a times c. And if I want to get c on its own, well, I need to get all my c's on one side. So I'll add bc to both sides, and I'll get ac plus bc. And notice now that both of these have a c in them. So the big brain play, we've talked about this previously. The only way to get c all by itself is to factor a c out, right? Both of these have a c in them. So I can write this as c times the quantity of a plus b. Right, if I were to distribute the c, I'd get back to ac. And if I were to distribute the c here, I'd get back to bc. So this is the same thing as this. But what's nice about this is I can see it's c times something, right? C times something. And if I want to simplify that and get c on its own, I can divide now by a plus b to both sides. And I did it to every term, right? This includes the c. Anything divided by itself is 1, so these go away. And I get 1c. And over here I get x over a plus b. So one of those big brain plays that you want to get down in your notes is that when you're here and you want to get c on its own, factor the c out so that you can divide what's left over, right? That's going to get you the c on its own. And that is it for this week.